Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review everything you need to know for next week's test on measurement. So let's start with perimeter and area of basic shapes. So let's look at the perimeter and area of each of these shapes. So firstly, let's start with the rectangle. So of course, you probably know perimeter just means the length around the outside of the shape. So this would just be 7 plus 5, but we have to add all four sides. We've only added 2, so we need to add another side, because this side here is 7, and we need to add another 5. So 7 plus 5 plus 5 gives you 24, and because the sides were in meters, it's 24 meters. How easy is that? So to find the area of a rectangle, it's very simple. You just times the length and the width together, the two dimensions together. And the area would be 35, but of course area is measured in square units. So the area there would be meters squared. Let's now look at the triangle. Perimeter is again very easy. It's got 3 sides, so we just add them all up. 8 plus 6 plus 10, which gives you 24, and of course it's in centimeters. So the area of a triangle is base times perpendicular height over 2. Whenever you see a h in any formula in measurement, it always means perpendicular height. So this would be base times perpendicular height over 2, which is 24, and it will be, again, in square units. So note, we didn't need the 10 side to find the area. Sometimes you will be given an extra side. Don't always assume that just because you're given a side length, you actually need it to calculate area or perimeter. So the third shape on here, the blue shape, is the parallelogram. It has 2 pairs of parallel sides. It's kind of like a rectangle that is slanted. So to find the perimeter is again pretty easy. We just add the sides. Just like for a rectangle, opposite sides of a parallelogram are equal. So this side and this side are both equal to 10. This side and this side are both equal to 12. So the perimeter, the sum of all sides, is just 10 plus 10, because there are 2 sides that are 10, 2 sides that are 12, and so I get 44 millimeters. Okay, so note we don't include that dotted line inside the shape. Perimeter is the length around the outside of a shape. Now to find the area of a parallelogram, it isn't 10 times 12, it's base times perpendicular height. Once again, h means perpendicular height. This here is the perpendicular height as shown by that right angle there. So the area of this parallelogram is 10 times 8. We don't divide by 2 for a parallelogram. That's for a triangle. So it'll be 10 times 8, which is 80 millimeters squared. Okay, pause and copy this down if you need. I'm about to show you 3 more shapes. Let's look at these 3 shapes now. The first is a kite, the second a trapezium, and the third a rhombus. So for the kite, its perimeter is pretty easy. We just add together all 4 sides. So kites have adjacent sides, so sides next to each other that are equal, whereas like a rectangle had opposite sides equal. So you probably know that these 2 lines here mean that those 2 sides are equal, so there's 2 sides that are 9, and similarly, this line and this line mean those 2 sides are equal, so they're both 10. So then we get answer 38 meters. How easy is that? Now, the area of a kite is xy over 2. X and y are the 2 diagonals. Now, people get a bit stuck here because they think a diagonal line has to be a line going like that. It doesn't. Diagonals are just the lines inside the kite that join opposite vertices. So the 2 diagonals of the kite above are 7 and 8. So the area is just going to be the 2 diagonals multiplied together divided by 2, which gives 28, and of course the answer's in square units. So actually, when you're finding the area of a kite, you don't use the sides on the outside at all. So for the trapezium, this one again is going to be simple. It's a 4-sided shape, and it has 1 pair of parallel sides. So we're just going to add together the 4 sides on the outside. We don't need the 4 meter side because that's inside the shape. So you get 56 meters there. So the area of a trapezium is a bit complicated. H over 2. Once again, H means perpendicular height, and you multiply that by the sum of the 2 parallel sides. A and B are the 2 parallel sides. So for the trapezium above, its area will be 4 over 2 times the sum of the two parallel sides, and that of course gives us 92 meters squared. Now the third shape here is a rhombus. It turns out a rhombus is a type of kite. It's a special type of kite that has all four sides equal. It's also a kite but a parallelogram as well. It has two pairs of parallel sides. A rhombus is sort of like a square that's slanted. So the perimeter of this shape, it would just be 4 times 5, because all four sides are equal. That's what these lines mean here. So the perimeter will be 20, and in this time it is millimeters. So because it's a kite, we're going to find the area the same as we found a kite. We're going to multiply together the two diagonals. So this diagonal here is 10, that's one diagonal, times it by the other diagonal and divide by 2, and you get 35 millimeters squared. How easy is that? So now we're going to move on to circles. Once again, please pause and copy down if you need. So you already know what a circle looks like, so we're just going to put a dot in the middle of it. So the edge of the circle, that black distance there, is called the circumference. We don't call it the perimeter because circles technically don't have any sides. So the distance from the circumference to the center of the circle is called the radius. Now the radius is the same wherever I draw it. It doesn't matter if I draw it there, or I draw it here, or I draw it there. All those three blue lines are the same length as long as they start at the circumference and go through the middle. So the distance from one side of the circle to the other, but through the center, is called the diameter. So this here is a diameter, which I'll call D. And once again, doesn't matter where you draw it. That length is the same as this length here, the diameter, as long as it goes through the circle. So the diameter is always double the radius. It's important you know diameter and radius because they help us calculate the circumference and area of a circle. So the circumference of a circle is the diameter times pi. It's also twice the radius times pi, 2 pi r. That's because this 2 and this r are the same as the diameter. So remember, pi is just a number. It's irrational, goes on forever. It's about 3.14159. It's just a button on your calculator. So let's say we had this circle here. The diameter is given to you as 10 centimeters. So we're going to calculate the circumference and area of this circle. So for the circumference, we just take the diameter and times it by pi. And if you do that on your calculator, you get 31.4159 blah, blah, blah. So it's 31.4159 for 4 decimal places. So make sure you're clear in the test on the question. Is it asking 2 decimal places, 3 decimal places, whatever. So to find the area is given by pi times r squared. So you need the radius to find the area. Now the diameter here is 10, so the radius is half that. The radius of this circle is 5. So if you put pi times 5 squared on your calculator, you get about 78.54 to 2 decimal places. Now what we need to make sure we do, which some people forget, is to write the units. Otherwise we're not correct. So the circumference is just in units of length, like centimeters, meters, or whatever, and the area is in square units. So this would be centimeters squared. How easy is that? Now we're just going to look at half circles. Now we look at this semicircle and we'll calculate its perimeter and area. It makes sense to think about the perimeter of this shape because it has a straight edge. It does have a side. So let's look first at the perimeter. So obviously we need to find this curved length here and then add it to the straight edge. So that curved length that I've just colored in blue, so it's half a circle. So the way we find the perimeter or circumference of a circle is we multiply the diameter times pi. Now because this is half a circle, we need to divide by 2. But that just gives us this blue length here. We also need to include this side here. So we need to add 6 to our answer. So to 2 decimal places, that's about 15.42, and of course, perimeter is always in units of length. So let's now look at the area. So if I want to find the area, remember it's pi times radius squared. Now, the radius is, again, half the diameter. So if the diameter is 6, the radius is 3. So the area of the full circle with diameter 6 would be pi times 3 squared. But this is only half a circle. Once again, I need to divide by 2. Now, when I'm finding the area, I don't need to add the straight edge of 6 because the area is the same whether that edge is there or not. We're not looking at the length around the outside. So the area is just going to be pi times 3 squared divided by 2, and we get about 14.14, and of course this is in square units, all right? Now we're going to turn our attention to composite shapes. We're going to find the area of these 2 composite shapes on your screen. So these are not standard shapes by themselves. The first one is 2 shapes stuck together, and the second one is 1 shape cut out of the other. So when you're finding composite shapes, you're either going to be finding areas and adding them together or subtracting one area from another. So if we look at the first shape, we have a triangle and a semicircle. So if this distance here is 12, that's the diameter, then the radius here would be 6. So that means that this distance here, the perpendicular height of the triangle, would be 22 minus 6, which is 16 centimeters. So the area of the triangle, remember, it's base times perpendicular height divided by 2, and that gives us 96 centimeters squared. Now we have to find the area of the semicircle. So we know how to do that. That's pretty simple. It is pi times radius squared divided by 2. And that gives us approximately 56.55. Again, it's centimeters squared. So the total area is just these 2 added together, because this is a semicircle plus a triangle. So if you add 96 to 156, you get about 152.55 centimeters squared. How easy is that? So let's look at the next shape. So notice we want to find in this one the area in blue. So we have a circle cut out of another circle. So the area of this shape, this time we are subtracting. We are subtracting the area of the small circle from the area of the large circle. So it will be the area of the large circle, which is pi times radius squared, minus the area of the small circle, which is pi times radius squared again. And you can put that straight in your calculator. You get about 235.62, and again, it is units squared. Now we're going to look at a quick example of a composite shape where you will have to do the divisions yourself. So again, please pause and copy this down if you need. So let's say I want to find this area here. Well, I can't use just normal formula. We don't have one for this. This is actually a weird looking pentagon. It's a 5-sided shape. So if we get a shape that we've never seen before, we're probably going to have to divide it into shapes we have seen before. So if I draw a line across here, parallel to the top and the bottom, I now have a trapezium and a rectangle, and it's easy to do. The area of this rectangle here is just length times width, 12 times 4, which is 48 centimeters squared. So the area of the trapezium, so remember, that is perpendicular height divided by 2. Now, if it's 4 from here to here and 10 from here to here, this part here must be 10 minus 4, which is 6. So I'm going to need that to find the area, because the area is perpendicular height divided by 2 times the sum of the 2 parallel sides. So putting that on your calculator if you need just gives me 63 centimeters squared. So the total area is just 63 plus 48. Add the 2 shapes together, 111 centimeters squared. So the last thing we're going to do for area is converting square units. Please pause and copy this down if you need. So we're probably familiar with these units of length. So we're going to look at how to convert, how to go from millimeters to centimeters and so on. So people find this confusing. And a lot of the time, the confusion is, do you multiply or do you divide? So the rule is, if you are going from a larger unit like centimeters to a smaller unit like millimeters, you times, because there are more of the smaller unit. There are more meters than kilometers. And so the opposite is true. If you're going from a smaller unit to a larger unit, like millimeters to centimeters or centimeters to meters, you divide, because there are fewer of the larger units. So you should know by now there are 10 millimeters in a centimeter, there are 100 centimeters in a meter, and there are 1,000 meters in a kilometer. So it turns out when you want to convert square units, everything becomes squared. So if you want to go from millimeters squared to centimeters squared, you need to divide by 10 squared. All the conversion factors get squared. So for example, if we had 2 kilometers and wanted to move to meters, we follow here, we times by 1,000. So 2 kilometers is 2,000 meters. But if we had 2 kilometers squared and want to convert to meters squared, we need to times by 1,000 squared. So there are 1,000 meters in a kilometer, but there are actually 1,000 squared or 1 million square meters in a square kilometer. So 2 kilometers squared would be 2 times 1,000 times 1,000 again meters squared. So make sure when converting square units, you square the conversion factor. It turns out that when you're converting cubic units, you need to cube the conversion factor. So I'm going to show you an example of that. Please pause and copy this down if you need. So if I say want to go from millimeters cubed to centimeters cubed, I need to divide by 10 cubed. That's right, everything gets cubed or converting cubic units. If you had, for example, 220 centimeters and wanted to convert it to meters, well, that's easy. Centimeters to meters, we're up here. We divide by 100. So 220 divided by 100 is 2.22. So 220 centimeters is 2.2 meters. But if I had 220 centimeters cubed and I wanted to convert it to meters cubed, I need to divide by 100 cubed. So if I want to convert this to meters cubed, I don't cube the 220, I only cube the conversion factor there. And then the answer I get is 0.00022 meters cubed, okay? So there are heaps and heaps of centimeters cubed. Turns out there are, again, 1 million centimeters cubed in a meters cubed. All right, let's now look quickly at volume and capacity. So we're now going to calculate the volume and capacity of each of these 3 prisms. So the first is a rectangular prism, the next is a triangular prism, the third one, yeah, okay, it's technically not a prism, but we do it the same way. It's a cylinder, so it's basically like a circular prism. So we're only looking at the volume and capacity of prisms. The rule is V equals AH. Volume equals area of the base times height. That works for any prism. So let's look at the rectangular prism. So the base, or the bottom of this shape, 40 times 30. That's the area of the rectangle at the bottom. So we take that and we just multiply by h, which again is the perpendicular height. So the answer we get is 60,000. This is now cubic units. So this is 60,000 centimeters cubed. So we look at the next one. The volume is the area of the base times the height. Now, the base doesn't always have to be on the bottom of the prism, however. So the base of a triangular prism is a triangle. The base is the shape that is repeated. So you can see that there's a triangle at the front and the back. If a shape's not repeated, it's not a prism. So the area of the base is the base of the triangle times the perpendicular height divided by 2. That's just the area of the triangle, and then we times it by the height of the prism, which is 12. So the answer we get there is 288, and of course this is in meters cubed. So let's now look at the cylinder, which is basically a prism. So the shape that's repeated is a circle at the top and the bottom. So the area of the circle is pi times radius. So the radius is again half the diameter. Pi times radius squared, that's the area of the circle, and I then need to multiply it by the perpendicular height. So get a very big number there, which is approximately 84,823 millimeters squared. I'm just rounding it to the nearest whole number. That's easiest for me here. So that is the volume. That's how much three-dimensional space will fit in each of these. So let's look at capacity. So really, to find the capacity, you only need two conversions. A milliliter is the same as a centimeter cubed, and 1,000 liters make up 1 meter cubed. If you know those conversions, you'll be right. The only difference between volume and capacity is the units. Volume, as we saw, is measured in cubic units like centimeters cubed, millimeters cubed, or whatever. Capacity in things like milliliters and liters. So let's look at this first prism, the rectangular prism again. It holds 60,000 centimeters cubed. So because a mil and a centimeter cubed are the same thing, its capacity is the same number of milliliters. So this would hold 60,000 milliliters. Now, we might like to simplify this. There are 1,000 mils, 1,000 milliliters in a liter, so this would just be 60 liters. Okay, how easy is that? Now, if we look at the second one, it's in meters cubed, so we're going to want to convert it to liters. So to go from meters cubed to liters, we just times by 1,000, because if 1 meter cubed is 1,000 liters, 288 meters cubed will be 288,000 liters, or if you like, 288 kiloliters. Now think about it, if you had a triangular prism that was 12 meters deep and it was, 6 meters high, that's huge. That's like almost the size of a building. So we'd expect that it would hold heaps and heaps of liters of water. But let's look at this last one. How do we go from millimeters cubed for the cylinder into milliliters or whatever? Well, we know a milliliter is a centimeter cubed, so we're going to convert this into centimeters cubed. So remember, if we wanted to go from millimeters to centimeters, of course, we would divide by 10. But because we're going millimeters cubed to centimeters cubed, we want to divide by 10 cubed, which is 1,000. So this would be about 84.823 centimeters cubed. So to get from here to here, I just divided by 1,000. So of course, 84.8 centimeters cubed is just 84.823 milliliters, because a centimeter cubed is a milliliter. All right, the very last thing I will do on this video is go through a couple of quick examples where we're finding a dimension. Please pause and copy this down if you need. So the key here is if you're given information about the area, or perimeter, or volume of something, and you're asked to find a dimension, so like a side length, or in this case, a diagonal, set up your equation, substitute in everything you do know, and rearrange to find what you don't know. This question here, area of a kite is 120 centimeters squared, one diagonal is 12 centimeters, we'll calculate the other. So the area of a kite is diagonal times diagonal divided by 2. So we're told in this case the area is 120, so let's rub that out and put 120 instead. So one diagonal here, it doesn't matter which one you call which, one is 12, so I'm just going to change x, the first diagonal, to 12, okay? So I've got 120 equals 12 times the other diagonal, divide 2. So 12 divided by 2 is 6. So I get 120 is 6 times y. You know how to solve equations. Undo everything that's been done to the pronumeral. Dividing each side by 6, we get 20 equals y. The other diagonal would be 20. And that's, remember, you have to divide by 2 for a kite. So the area of this kite would be 12 times 20 divided by 2, which is 120 centimeters squared, okay? It wouldn't be 10. And the area of the kite would only be 60. Let's look at another example like this. So for our final example, we look at a cylindrical can holding 300 mils of liquid, diameter 4 centimeters, we'll calculate its height. we're going to do this the same way. We're going to set up our equation. So we know that the volume, because this time we're talking 300 mils is volume or capacity, is pi times r squared, pi times radius squared, that's the area of the circle, times h, which is the height. So let's substitute what we do know. We know the volume is 300 mils. Now 300 mils is 300 centimeters cubed, because remember I told you a mil and a centimeter cubed are exactly the same. And if the diameter is 4 centimeters, the radius is 2 centimeters. So I'm going to substitute here r for 2. So what I've got is 300 equals pi times 4 times h. I want to get h by itself, so I undo what's been done to h. So what I'm going to do is divide each side by 4. And if I go 300 divided by 4, that gives me 75 equals, so dividing by 4 gets rid of the 4 on this side, 75 equals pi times h. Now pi is just a number, 3.14159, and so on. So if I want to get h by itself, I divide each side by pi, by this number. So h will just be 75 divided by pi, which is approximately 23.87 centimeters. How easy is that? So whenever you want to find a dimension and you're given information about the area, volume, or whatever, set up your equation, substitute what you do know, and rearrange to find what you don't know. Alright, sorry for the long video. Best of luck in the test, but you're a superstar. I know you'll succeed. This has been the luckiest maths teacher in the world. Have a great day.